Hi, my name is Boris, and I'm one of the SORA developers. And today, we're excited to host a small knowledge sharing session on cross-chain communication. So this presentation will mostly be focused on the implementation of cross-chain consensus communication within the Kusama ecosystem. This is the first part for the reason that still there is no real implementation for SORA and no real solution that could be shared in details. So therefore, within the framework of this session is planned to give a theoretical basis as well as a simplified implementation. So we're going to start with the context and relevance, and we're going to switch to the technology. We will present a small demo on the dummy implementation and how it's basically done now. Then we're going to raise some questions about the future and the present of SORA state and its potential implementation of XCMP and HRMP. And finally, we have a Q&A part. I would like to start with a small ecosystem overview. So shout out to Mitya for this schema. It's just gorgeous, and it's very detailed, and actually it doesn't show the whole SORA ecosystem and all its components and all its partners, and I would say programs. So I decided to simplify the schema a bit, so we're just staying more focused on the relevant components that we're going to talk about today. So SORA is built on parity substrate, as you may know, and SORA is a standalone blockchain. It's also planned to utilize the parachain on both Kusama and Polkadot, along with the many connections with bridges. So you know that SORA is a both economic system and as well as a network which implements a new way to architect the parachain blockchain that connects to the Polkadot relay chain with the built-in tools focused on DeFi, and that implies the desirability of having as many sources of liquidity as possible. And we're planning to bring this liquidity from Polkasama ecosystem. Let us also have a quick recap of the Polkasama entity. So we have a relay chain, which is the heart of the Polkadot, responsible for the network's shared security, consensus, and cross-chain interoperability. We have the parachains, the sovereign blockchains that can have their own tokens and optimize their functionality for specific use cases. We got the par threads, which are similar to parachains, but with a pay-as-you-go model. We got the bridges that are allowing the par threads to connect and communicate with external networks like Ethereum and blockchains. That being said, the Polkadot mission is to build a scalable blockchain future, which means by means of multi-chain architecture, where every separate blockchain is customized to the specific needs of the whole system. So it's also usually being overviewed as a heterogeneous sharded system. But as another essential focus of Polkadot, and I guess of every blockchain, is security. So the obvious sharding approach, taking what the Polkadot is to assign different common good function so that relay to the parachain, so that relay chain may focus on cross-chain communications instead of other specific business logic, which is like loading the relay chain itself. So for instance, you can have a separate dedicated staking parachain, which will eventually have the single function staking. So that could be, other examples could be the auction chain, the governance chain, and so on. Keeping that in mind, Polkadot is trying to build the interoperable ecosystem, and they started to work at the solution. So if there anyone from the design team at this session, so please don't mind the selection of the colors. Hopefully it's not that terrible. So it's not possible to just make a call from chain A to chain B for many reasons. The most trivial one is that at some point chain B could be updated. And essentially, the call itself is just a binary bluff. So after the update, the call just may fail. And that's why they're taking the solution of the creation of something that is called the executor, which will handle all the upcoming messages. And so it doesn't matter how logic has been changed within the update of chain B. It's ensured that the messages are handled and routed correctly. But of course, in order for executor to understand what to do, it has to like have the standardized. It has to have the certain format that could be parsed. And imagine if like every parachain in the Polkaswap ecosystem had a separate format created and required to be implemented on the other parachains so that they know how to communicate. And that's not efficient. So that's why XCM was created. So what is XCM? XCM is a messaging format. It's not a protocol. An XCM message is just a set of encoded bytes and needs to be interpreted by executor. The executor executes operations based on the message contents and maintains the internal state. So XCM can be used to facilitate communication between different types of consensus systems, not just chains. So that includes messages between smart contracts and their environment, messages between sovereign blockchains over bridges, and between shards, the parachains, etc. It's also support common use cases on chains that might not be handled by a single transaction. So for instance, when from one chain you want to call some transaction or anything else on the different chain. Yeah, and XCM is backwards and forward compatible. So already there are 3 versions released. Every version has different capabilities in terms of the compatibility, but I would say that it's not critical for SORA now, because we're yet dealing with the trivial use case. We're dealing with so-called teleporting, aka bridges. So I guess the version is not the selection of version is not that critical for now. So yeah, if you want me to expand this topic, so please just raise the question during the Q&A session so we can talk more about it. So let me for now please move to the next slide. Those use cases are taken from the official Polkadot website. As you can see, everything could be moved to the separate parachain. So it could be NFT staking, it could be multi-chain smart contracts, batch transactions, doesn't matter. At the end, any arbitrary message passing could be implemented within the XCM, and basically there are no limitations how to handle and execute it. So there is also a great example showcased during the Polkadot Decoded 2022 just recently in Berlin. So yeah, the XCM format also can be used to send messages from the Ethereum smart contract. Yeah, it will go for the Ethereum breach to over Polkadot connected to the Ethereum breach across then across the parachains via the XCMP or HRMP and all the way to the Inc small contract, and that way, yeah, enabling the cross consensus communication. There are 4 ways placed as a fundamental during the fundamental design of the XCM. So XCM messages are asynchronous, meaning that the sender doesn't have to wait for the messages to be processed before continuing. They're also guaranteed to be delivered accurately and in a timely fashion. Asymmetric messages do not have results, so any results must be communicated to the sender separately. Lastly, XCM is agnostic to the consensus system between which messages are being passed, meaning that it makes no assumptions about how message will be processed. Let us talk about a bit how XCM is working under the hood. So yeah, a message in XCM is actually just a program which that runs on the XCVM, XC virtual machine. So it is one or more XCM instructions. So instructions are just the building blocks of the message. The program executes until it either runs to the end or hits an error, at which points eventually it finishes up. So one example of instruction is transfer asset, which is used to transfer an asset to some other address on a remote system. It needs to be told which asset to transfer and where to transfer. There are 2 fields that define the asset. It's ID and fun. An asset identity must be provided first. Of course, the it can be expressed in two ways, either concrete or abstract. So yeah, let's not dig into it for now. And yeah, assets are primarily administered within the chains palette, may be identified by a location, including their index in the palette. So in the right part of the slide, you can see that if the XCM message is called from the parachain, it first being transferred to the relay chain. So these two dots would be maybe familiar with you if as you probably like ever like worked with any operating system or just any folder system format that is being like used in all popular operation systems. So yeah, first it's coming to the relay chain itself. So as relay chain is considered to be a parent of the parachain, then it's coming to the parachain 1000. Then it's eventually leading to the palette instance 50 and finishing up to the index of this specific palette 42. That's about the location. I'm gonna talk a bit more about it a little bit later. But yeah, secondly, assets must be either fungible and non-fungible. If they're fungible, there should be some associated non-zero amount. If they're not fungible, then instead of an amount, there should be some indication of which instance they are. I've shown here. So let's mention the first example. The statement is evaluated within the parachain and would identify other symbolic parachain of index 1000. Yeah, for chains that trust each other, a framework that Polkadot calls teleporting, so AK bridges. I don't know exactly why is it called teleporting, but you could probably enlighten me after. So this basically just means destroying an asset on the sending side and minting it on the receiving side. So this is simple and efficient. It only requires the coordination of two chains and only involves one action on the other side. So yeah, on the slide, there is an example how XCM would like which teleport one dot from the Polkadot relay chain to its sovereign account on a parachain. As you can see, the sender chain is creating a whole new message which executes the initiate teleport instruction. It takes the XCM field and places it beside a new XCM and send this XCM to the receiver chain. The receiver chain trusts the relay chain to have destroyed one dot on their side prior to sending the message. Everything in the XCM parameter is written from the perspective of the receiving side. So despite this being a part of overall XCM, which is fed into the Polkadot relay chain, it's only actually executed on the parachain itself. So when parachain gets the message, it looks like an inner XCM object, so presented on this slide right here. From the, yeah, it just looks like to the inner part. And so what important to understand is that XCM is a just a hierarchical way of formatting the message as probably JSON YAML is. So I guess that's all about the XCM. So let's switch from the format to the protocols that are capable to handle this format for now. Yeah, I would like to mention that all protocols are yet Polkadot specific, and XCM is yet Polkadot specific due to the absence of actual implementations on different ecosystems. So yeah, let's take a look at some terms. So starting with DMP, this is a protocol for how message is sent from the parent relay chain to the child parachain. The opposite is UMP, where the protocol for how message is sent from child parachain to relay chain. And XCMP is the most interesting one, and in particular the SORA is interested in. So it's an acronym for cross-chain message passing. Specific, it's specific protocol for how messages are sent between siblings parachains. So exactly what we're interested in. So coming back to the schema, to basically enable the interactions between all other parachains and SORA parachains. Yeah, it's important to understand that XCMP is still under the development, and its current iteration is called XCMP Lite, aka HRMP, which is standing for Horizontal Relay Message Passing. So the main difference between XCMP Lite and the final production version of XCMP is that XCMP Lite, aka HRMP, currently uses the relay chain to facilitate the passing of messages. Whereas the goal for XCMP is not include the relay chain at all for such messages. Yeah, talking specifics. I might say that this code was taken from the official Polkadot repo, the master branch, and already been used and implemented within some parachains, which already onboarded the XCMP. So as you can see, generally the XCM is a generic overcall, which can be used to describe a set of dispatchable functions exposed by the recipient of the message. So here you see how most useful instructions like transfer asset or query response and etc. are standardized and implemented. It allows to have a consistent language no matter which chain you talk to, basically. So, with the transaction, with the instruction like transact, which is also present on this slide, the unlimited flexibility may be achieved to call any non-standard function on the other parachain or consensus system. The implementation of executor is quite simple. So in order for messages to be processed, it must be interpreted by the same executor. So it executes the operation based on the contents of the message and maintains the internal state throughout the execution. It's very modular, very configurable. So many different threads are used within the implementation. And for most of this, there are even more generic builder structs that could be used to easily implement these configurations. As you can see, the execute function is just iterates over all instructions, XCM instructions, and basically calling the process instructions, which is in turn is just a large match pattern, and it makes sense. So I guess it's time for demo. We have prepared a simplified implementation of the SORA assets for this presentation, which Dmitry will demonstrate. Also in order to save some time, we'll skip the process of starting nodes, launching the validators, registering parachains, and other technical not important processes. So Dmitry, you have the floor.
Hello. So I prepared a simple local relay chain and parachain networks. It consists of local Rococo test networks with 2 parachains. It's just our SORA parachains that are registered as different chains, so they are identical. I already established an HRMP channel in one direction from parachain 2000 to parachain 2001. So the first thing why I did this, it's because it could this HRMP channel could be created really long. So to make it faster, I pre-created it. So now there were questions about creating HRMP channels. So there is a simple example of creating it. It just we use palette Polkadot XCM for this, like in documentation in official Substrate website. So also I want to mention that these HRMP channels, they are created on a relay chain side. So if a XCMP protocol will be like more decentralized, but HRMP, it's a temporary protocol, so it's managed by relay chain. So to create this HRMP channel, we just send an XML message to our parachain. We just withdraw our asset because we launch this transaction on parachain through our parachain sovereign account. Sovereign account is an account that is represents parachain in relay chain, and this transaction must be the transaction origin must be parachain. So yeah, I already created it all. So it's just we withdraw asset, this native assets. We buy execution because we need to pay some fees to do that, and launch a transaction there. And I must say that, like in a guide, this transaction is already encoded. It's just in launching these commands on our relay chain. So yeah, let's try create it. Here now we trying to initiate this creation. Yeah, and on the relay chain, on parachain part, the transaction executed quite slow. Yeah, this transaction succeeds. So in our events, we see that HRMP open channel requested. So from the downside, it could be requested in answer. So we will not do this today because it's just quite simple, the same transaction, but yeah. Okay, and now about assets. Why this HRMP channel is required? They're required to allow our parachains horizontally talk to each other, send messages to each other, and sending, for example, sending assets is also in some kind of message. Yeah, here on this simple example, we use two pallets, pre-created pallets, ORML tokens and ORML X tokens. X tokens uses XCM executor directly. So tokens is just simple tokens. So these tokens are required to map to some kind of XCM representation, and I had to write some mappers, but okay, yeah, we have this. I named this SORA, but it's just a dummy token. Yeah, and this account has this amount of tokens, just pre-created it. So yeah, and now what we want to transfer these tokens to other parachain, to Alice on this site, on parachain 2001. Yeah. So what we just use transfer multi-assets. So it could be there are several other extrinsics, but now to show just how to do it in general, I just chose transfer multi-assets. So we transfer this amount of tokens and say that we transfer it to destination per chain 2001 to account to this Alice account. The same. Yeah. And of course, I'm sorry, here. Yeah. We don't have this assets here. So yeah, it can execute really slow too here. Just have to wait some time. All blocks executed here. And here we have events that's something completed, something sent. So we received some tokens here. See, it's in events. Yeah, it's we had to buy some fees or spend some fees, so it's it is not the full amount of tokens. So yeah, we received it. Yeah, and what's next? Next, we want to adopt. Now we work on adoption these palettes for our aims to make it compatible with SORA 2 mainnet, I mean, and to make it be transferable through to other parachains and to make other parachains tokens be transferable to our parachain.
As already been told, we have a lot of things to think about and eventually implement. And it's important to understand that yet we don't have a good solution for the implementation of assets. What we just shown you was just a dummy implementation, which isn't really compatible with the current assets implementation on SORA mainnet itself. So we somehow have to align it and make it work. This is the problem number one. The second problem is that we do not have the second part of the bridge, which is going from the SORA parachain to SORA mainnet. Yeah, in general, there is no connector between the bridges now, and this is also going to be heavily affected by the first point, which is not really clear for us. But yeah, that's something we'll have to investigate. Yeah, Polkasama.sama. Sorry, there are many ways to put it, so I just chose this one. Do instructions correspond to the extrinsics IK runtime API calls? Ask Vladimir. Instructions is being handled by executor, which is able to basically be connected to any palette, to any config. And eventually the executor itself may make the extrinsics themselves. So Dmitry, could you probably give more technical overview about this question?
You're right. So this executor is just an executor, and any palette that can call its function can execute it on a transaction extrinsic. Yeah.
Perfect. Bogdan is asking if there is a way to verify on the target chain that the message Yeah, Bogdan, could you please open up your question and maybe expand it some form?
Yeah, sure. So as far as I understood, the XCM format just, expresses some operations, just claims that something has happened in the source chain, right? But from the receiver perspective, how could I verify that it's like not lies? So this source chain is not malicious and, produce some truth messages in relation to the real operations happening on the chain?
Yeah, it depends on the custom implementation, which should be done by the each parachain separately. But we also consider the cases when the parachain is trusting another parachain. So that is also the case, but if one is not transferred. So I guess one scenario would be to use a different implementation for the bridge. So for instance, if the bridge implies the burn of the assets on the chain A and the minting on the chain B consequently, so those have to trust each other. But if the bridge is implemented in the form that the parachain A is reserving the assets on the relay chain, and those assets are like consecutively wrapped and basically minted on the parachain B, that doesn't imply any trust between the chains. So because the chain B isn't using the asset A per se, they're using the wrapped version of them. And that's one way to solve it. The other way, again, this should be a custom implementation. So it's always possible to get the encoded call data in the form of the hash and just check the hash. And if there's something like a runtime upgrade, which is planned to be done on the chain A, which eventually might affect the call itself, the hash will change. So Dmitry, could you please maybe give more technical review on that question?
You're right about custom implementation, and every parachain chooses custom implementations, and there are some ways to filter some filters, make some filters, barrier, etc. So it's still not under our investigation how to make it work safe. But there are some built-in filtering and mechanism for this.
Yeah, exactly. There are like many ways to implement it, and I just mentioned only two of the protection mechanism that could be used. So does this answering the question, or may we miss something, Bogdan?
Yeah, I guess so. It's just a bit of perspective for this question. And so to my conclusion, it seems that audit is still gonna happen, and it closely relates to the concept of checking like Ethereum smart contracts for a breach or so. So this is just about the format, which does not imply any security.
Well, the XM message, yes. As already said, a lot of presets already like delivered within the official version of those XCMP, of those like XCM message handlers such as XCMP and HRMP. But if you want to have your custom like business logic, of course, you have to do the audit of the other chain and filter it, I don't know, by the hash of the call data or something else. Just many ways to put it.
Okay, got it. Thanks.
Perfect. Thanks. There's also a question from William. Why does there is a need to be a public referendum to open a HRMP channel between chains? Good question. The simplest way to answer would be, I don't know. I wasn't the one who was designing it, but I must say that maybe for the reason that HRMP implies the relay chain as a we'll say centralized entity that is being a provider, a proxy layer between two parachains. So imagine that there is like a way to create an infinite amount. Yeah, not that an infinite bad example, but imagine that every parachain would like to at the same time connect to each other and like spam a lot of requests. So you have to make a handshake with a relay chain to make it work. is there only one executor, and what happens if it goes offline? Yeah, Dmitry, please correct me if I'm wrong, but executor is on chain, so it doesn't go offline. It's not off chain, so it goes offline in a single case when the whole chain, the whole validators go offline. So yeah.
It's a built-in to runtime in palette that uses it, like X token, for example.
Yeah, I think it would be possible to make it off-chain, but it wouldn't be a good design after all. Yeah, summing up, there are a lot of things to solve on our side. And once we do it, we'll be excited to present the real solution. We'll be excited to attract more and more liquidity to SORA.